So guys, before we start discussion of our algorithm for implementing IPv4 routing table, we need to get ourselves familiar with certain representations that we will going to follow. So as I said, we will going to use mtry data structure in order to implement routing table, and mtry is a tree-like data structure, so obviously mtry will going to have nodes. We will call those nodes as mtry node. Alright, so this is the diagram which shows a typical mtry node which will be used to store routes. So each node of an mtry will going to store route. So let us discuss with the help of an example that how each node in an mtry will going to store information. So let us suppose that we have a route 1.2.3.4/24. So we will going to express this route in terms of prefix and wildcard. And obviously for IPv4 routes, the prefix len is 32. So following is the effective prefix that we will going to derive from the prefix and wildcard combination. All right. So as I said, each node will going to store the information regarding route. Each node will going to store the effective prefix, the prefix len, and certain pointers which points to its child nodes. The child nodes we will going to discuss later when we will actually discuss the algorithm. So the mtry node which will be used to store this particular route would look something like this. This is the effective prefix. This is the prefix len. All right. Similarly, if I have a 16-bit prefix and a 16-bit wildcard, then the effective prefix would be this one. And the mtry node that we will going to store this information would have 16-bit effective prefix, and this is the prefix len. All right. Now note that each mtry node may store a part of the route or the entire route altogether. There is no restriction. So now if I were to ask you that can you write a data structure definition which represents an mtry node optimized for storing routes? So you would say that this is such a data structure. As I said that each mtry node would going to store effective prefix, and effective prefix is stored as a combination of prefix and wildcard. Therefore you would need two bitmaps in order to store prefix and wildcard separately. But together they represent an effective prefix. All right. Bitmap is nothing but you can visualize bitmap as an array of bits and nothing else. All right. Prefix len we already know. In this case the prefix len is 32. In this case the prefix len is 16. So number of bits in the prefix and total number of bits in the wildcard is the prefix len, and prefix len of the prefix and wildcard is always going to be same no matter what. All right. Then each node contains a pointer to the parent and each node contains the pointer to its children. This we will going to discuss when we will be actually discussing the algorithm. Each node also contains some data which we will going to discuss when we will be discussing the algorithm. All right. So the point here is that you should understand the mtry node data structure and how we will going to store the effective prefix in this data structure as well as the prefix len. And finally, we need to discuss how to represent the root of the mtry. So as I said, mtry is a tree and every tree has a root. In our case, our mtry data structure has a root which is actually a special node in the mtry and differs from rest of the nodes in the mtry. So root of the mtry will going to be a special node and we need to discuss that. So this represents the root of the mtry, and the special thing about root is that it do not have any effective prefix and its prefix len is 0. So it means that this particular bitmap will contain all zeros and the wildcard also contains all zeros. The prefix len will be 0. The pointer to the parent will be null. And to initialize with, in the beginning when the tree is entirely empty, all the child nodes would point to null. All right. And the data part is also null. So this is what root node is And this is what mtry data structure would look like when the mtry data structure is just initialized. A freshly initialized mtry data structure will just contain a root node with everything initialized to null or 0. Alright. Now coming to this enumeration, as I said that each mtry node will going to have 3 children. These children are indexed in the mtry node as 0, 1 and don't care children. Alright. We will going to discuss in detail when we will going to discuss the algorithm that what does it mean by saying that this particular children is a 0th children or 0th child, or this particular children is a 1th child and this particular children is a don't care child. So each node in the mtry can have maximum of 3 children and we index these children as 0, 1 or don't care. And as I said, you need to visualize bitmap as an array of bits and nothing else. And on this array you can perform operations like you would have performed on normal arrays. For example, we can implement a function bitmap set at, pass the pointer to the bitmap and pass the index. So for example, if you pass the index number as 18, then this particular function must set the bit at index 18 to 1. Alright. So guys, with this we have finished with all the prerequisite details that we need to know before we start our discussion on implementation of IPv4 routing table. First, we will only going to focus on the algorithmic part, that is how we will going to insert routes in this mtry, how we will going to delete the routes from this mtry, how we will going to search for routes in this mtry, and how we will going to implement longest prefix match based search in this mtry data structure. Remember, this mtry data structure would be nothing but it is your IPv4 routing table in the end. So I hope you understood this structure. This structure is very much important in order to understand the algorithm. Once again, every node of the mtry will going to store the effective prefix, which is a combination of the prefix and wildcard, of course, the prefix len, the pointer to the parent, and the pointer to its children, and the additional application specific data. So now in the next lecture video, we will going to start our discussion with how we will going to insert routes one by one into a mtry data structure.